All right, how's it going, guys? This is going to be the second half of the Module 8 review, 13 through, I believe, 22. Yes, 22. So let's go ahead and get started. Number 13, or rather 13 through 18, we're told to write the polynomial function with least degree and a leading coefficient of 1 that has the given zeros. So we have 3 and 2i, and for number 13. So there's going to be two ways to go about it. The first way is the really long method. And how you do that is you're going to you're going to write each factor. So with 3, you get the factor of x minus 3. And you're going to multiply it with 2i, which will be x minus 2i. And remember, if you ever have an imaginary number or a root, they have to come in pairs. So you have the 0, 2i. You also have to have the root negative 2i. So we're also going to be factoring with x minus negative 2i or just x plus 2i. I'm not going to go through this way because it's really long and it's not my preferred way. But you're going to multiply all three of these polynomials together, and that will be your answer. Okay. The other way to go about it, that I like much better, is that we're going to set each zero that we have here equal to x. So we have x equals 3 and x equals 2i. All right. And now we're going to, let me back up real quick. For x equals 3, we're going to set that equal to 0. So we're going to minus 3 over. So you get x minus 3 equals 0. And for x equals 2i, anytime when you're using this method that you have an imaginary number or a root, what you want to do is you want to isolate the imaginary number or the roots, and then you're going to square both sides. Okay? What you do on one side, you do on the other. So we're going to square both sides. Okay? And we do this to get rid of the I and the square roots. So we get x squared equals 2i times 2i. 2i times 2i gives you a 4i squared. Okay? And 4i squared will give you negative 4, since I squared is negative 1, and negative 1 times 4 is negative 4. So we get x squared equals negative 4. And after you've gotten rid of the I or the square root, whatever you have, then we're going to set this factor equal to 0, so we'll add the 4 over. So you get x squared plus 4 equals 0. All right? So now we have our two factors, x squared plus 4 and x minus 3. Now we can multiply them together to x squared plus 4 times x minus 3. We'll multiply them both together, and when you do, you get x cubed minus 3x squared plus 4x minus 12. And it doesn't look like we have any like terms to add. It's already in standard form from highest degree to lowest degree, so we're good to go. We get x cubed minus 3x squared plus 4x minus 12. All right, so that's the method I like to teach, and I think it's a little easier than just kind of going about it the long way, just multiplying everything out with its zeros, or with its factors, sorry. All right, so let's go on to number 14 now. For number 14, we're going to go about it the same way. I'm going to erase this part right here to give myself a little more room. All right. So we have 3 minus root 5 and negative 2 as our two zeros. So we're going to do the same thing. We're going to set each zero equal to x. So x equals 3 minus root 5, and x equals negative 2. And now we're going to isolate the square root for the left one, because it just makes our life much easier when we square it. So we're going to minus the 3 over, and you get x minus 3 equals negative root 5. All right, so we move the 3 over, and now we're going to square both sides. And when you do, we can see x minus 3 is a perfect square trinomial. So we get x squared minus 6x plus 9. We could also just FOIL it out the normal way, or just multiply x minus 3 with x minus 3. You'll get the same thing. It'll just be much longer. And that's going to equal negative root 5 times negative root 5. We multiply the coefficients first, so the negative 1 times the negative 1 is a positive 1. And then root 5 times root 5 just gives you 5. Remember, when you multiply two square roots, you just multiply the two numbers underneath the square root and put it underneath the square root. So you get square root of 25, which is just 5. So 1 times 5 is 5. So we get x squared minus 6x plus 9 equals 5. Now we need to set it equal to 0, so you move it over. So x squared minus 6x plus 4 equals 0. That's one of our factors. Now we saw this factor up here if x equals -2, but that gets solved easily enough. We just move the 2 over, and we get a factor of x plus 2. So those are our two factors, and now we need to multiply them together. So we have x plus 2 multiplied with x squared minus 6x. All right, minus 6x plus 4. All right, we're going to multiply it all out. We get x cubed minus 6x squared plus 4x plus 2x squared minus 12x plus 8. Add like terms, x cubed minus 4x squared minus 8 minus 4x squared minus 8x plus 8. And that right there is a standard form of number 14. All right. So let's keep on going. Let's do number 15 really quickly. So we have 3 and 2 with a multiplicity of 2. Let's actually just keep doing this the way we just went about it. So we set each 0 equal to x. So x equals 3, x equals 2. And since we have a multiplicity of 2, it's going to happen twice. X equals 3, x equals 2, and x equals 2. We're going to minus the 3 over, set it all equal to 0. Since factors have to be set equal to 0, so x minus 3, x minus 2, and x minus 2. All right? So now we're going to multiply everything together. X minus 3 with x minus 2 and x minus 2. So just x minus 2 squared. And we can see x minus 2 squared is a perfect square trinomial. You do see these relatively a lot. Rather, I shouldn't say relatively, but you do see it a lot. So it is pretty worth your time to have these memorized. So x minus 2 squared will give you x squared minus 4x plus 4. All right? So now we can multiply these two together. You can use the box method if you'd like. I'm just going to multiply straight across. I'm going to use x and distribute it out to the second polynomial. So get x cubed minus 4x squared plus 4x. And then I'm going to do the same thing with the negative 3. Negative 3x squared plus 12x minus 12. I'll add like terms. And when I do, I get x cubed minus 7x squared plus 16x minus 12. And that right there is your answer for this problem. All right. Squared minus 4x plus 4 minus 12x. Yeah. All right. So let's go on to number 16. Number 16, we have 1 and 1 plus I, that's 2 zeros. We're going to do the same thing. Set each 0 equal to x. So x equals 1 and x equals 1 plus I. For the left side, we're just going to move the 1 over. X minus 1 equals 0. It's set equal to 0, so that's our factor now. For x equals 1 plus I. Remember, we want to isolate the I just to make our lives much easier when we square everything to get rid of the I. So we minus the 1 over, so you get x minus 1 equals I. And then we'll square both sides. And when we square both sides, we get x squared, or the left side anyway gives us x squared minus 2x. Sorry about that. So x squared minus, there we go, x squared minus 2x plus 1 equals I squared. I squared is just negative 1. So now we can add the 1 over and get x squared minus 2x plus 2 equals 0. Now that this is set equal to 0, that's a factor as well. So we can multiply x squared minus 2x plus 2 with x minus 1. So x minus 1 times x squared minus 2x plus 2. We'll multiply these together. And when we do, we'll get x cubed minus 2x squared plus 2x minus x squared plus 2x minus 2. Add like terms, x cubed minus 3x squared plus 4x squared minus 2. And that right there is our standard form of the polynomial for number 16. Okay? For number 17 and 18, I'm going to leave that for you guys to do on your own. We do post a completed key online, so you can double check your work there if you need to. But we're going to go on to the last page and start on number 19. Okay? So number 19, we're given the degree and a graph of the polynomials, and we need to figure out how many real zeros, non-real zeros, and total zeros that we have. So we're going to start with the total number of zeros. So I think that's one of the most useful things to have. And remember, the total number of zeros will always equal the degree of the polynomial. So the degree of the polynomial is 3. That means our total number of zeros has to be 3. Next, we're going to find our real zeros. Our real zeros, remember, is the same exact thing as our x-intercepts. X-intercepts and real zeros are the same exact thing. We have one x-intercept in this graph. That means we have one real zero. And if we're supposed to have a total of 3 real, if we're supposed to have 3 total zeros and we have 1 real zero, that means we have to have 2 non-real zeros. There we go. So 1 real zero plus 2 non-real zeros gives us 3 total zeros. Okay. Now for the next one, we have a polynomial in degree 4. So that means our total number of zeros is 4. Our real zeros will be the number of x-intercepts that we have. We have 2 of them. So we have 2 real zeros. And if we have 2 real zeros and we're supposed to have a total of 4 zeros, that means we have to have 2 non-real zeros. Next, degree 5, 5 total zeros, 3 x-intercepts, so 3 real zeros, and that leaves us with 2 non-real zeros. Next, degree 6, 6th degree means 6 zeros. We have 2 x-intercepts, so 2 real zeros, and that leaves us with 4 non-real zeros. Okay? So let's keep on going. 20, we're given one root of a polynomial with integer coefficients. We need to say another root. So remember, whenever you have a square, sorry, not square root, so you have a root or a 0 with a square root in it or an I in it, you have to have a pair with it. It always comes in pairs. And that's because of how the quadratic formula works. If you use a quadratic formula, you always come out with 2 zeros. And that's because you have the plus or minus there. So it gives you 2 zeros with the quadratic formula. All right. And because of that, the sign in front of the square root or the I is what's going to change between the 2 pairs. That's all that's going to change. So if you have a 0 of 3 minus root 5, you also will have a 0 of 3 plus root 5. You only change the sign in front of the square root or the I. All right, because that's where the plus or minus is in the quadratic. Next, we have 3 minus 5i, so we'll have 3 plus 5i. Next, 4 plus root 7 or 4 minus root 7. I don't know why I put a negative root 7 there, but it should be 4 minus root 7. There we go. Next, 2 plus 7i, so 2 minus 7i. Negative 2 plus root 3, or negative 2 minus root 3. Negative 5 plus 9i, negative 5 minus 9i. Negative 4 minus 3i, negative 4 plus 3i, negative 4 minus root 2, negative 4 plus root 2. You just change the sign in front of the square root or imaginary number. Okay? Next, we're going to state, for 21, we're going to state the degree of the simplest polynomial with integer coefficients that has the given zeros. So with root 3 and 4i, I remember we just talked about it. If you ever have a root or a 0 with a square root or an imaginary number, it has to come in pairs. So if root 3 is a 0, negative root 3 also has to be 0. You either have both of them or you have neither of them. So if root 3 is a 0, that means negative root 3 will also be 0. And if 4i is a 0, then negative 4i also has to be 0. So those are our 4 zeros for this polynomial here. The simplest polynomial we can have, the zeros root 3 and 4i. So the smallest degree that this polynomial can be is 4. And that's because if you have root 3, you have to have negative root 3. And if you have 4i, you have to have negative 4i. Next, we have this one right here, negative 3. and 2 plus root 3. Same thing here. If you have 2 plus root 3, you have to have 2 minus root 3. And that leaves us with 3 zeros. The negative 3 is just a regular number, not a regular number, but it's a number without a square root or an imaginary number with it. So it doesn't come with a pair. Next, we have 5 plus 3 plus 5. I think it's supposed to be 3 plus root 5. I think it was a little typo, so let's go with this one right here. 5 plus 3 plus root 5. If you have 3 plus root 5, we also have to have 3 minus root 5. Okay? So in this case, we'll have a degree of 3. Next, we have 2, root 7, and 5i. 2 doesn't have a pair with it, but root 7 does. You have to have negative root 7, and 5i also does, which is negative 5i. So that leaves us with a total of 5 zeros at the very least. So our smallest polynomial has to be 5. All right? And last, let's go over number 22. Number 22, they're asking us to list all zeros of the polynomial and state the multiplicity of each root. So remember, the multiplicity just means how many times that 0 happens. All right, so for the first one over here, we have 2 times x minus 1 cubed times x plus 1 to the 4th power times 2x minus 1 to the 5th power. So we're going to set each factor equal to 0. We're going to find our zeros first. So we have x minus 1. One of our zeros will be x equals 1. And we can see that it happens 3 times because it's x minus 1 is being raised to the 3rd power. So it's x minus 1 times x minus 1 times x minus 1. Or in other words, that x minus 1 happens 3 times. So if it happens 3 times, that means we have a multiplicity of 3. Next, we have x plus 1. That gives us a 0 of negative 1. And we see it happens 4 times. So it has a multiplicity of 4. And lastly, we have 2x minus 5. We set that equal to 0. You have 2x minus 1 equals 0. You end up getting 2x equals 1, or x equals 1/2. So x equals 1/2, and that will have a multiplicity of 5. Right, it happens 5 times, so that's what we get. Number 2, we have x minus 2, so we have x equals 2 with a multiplicity of 2. X plus 2 is keep consistent. X equals negative 2 with a multiplicity of 3. And 2x minus 1 will give us x equals 1/2 with a multiplicity of 4. And lastly, we have 3x plus 2. If you solve that for 0, you get negative 2 over 3. And that gives us a multiplicity of just 1, so we don't need to write anything. Next, we have x equals 3 for x minus 3. It's raised to the 2nd power, so it happens twice. So it has a multiplicity of 2. And lastly, we have x minus 1. You solve that for 0, or sorry, solve that for x. When you set it equal to 0, you get x equals 1. It's raised to the 3rd power, so it happens 3 times. So it has a multiplicity of 3. All right, so that's the whole review, guys. I hope this was helpful, and I hope you learned something, guys. Have a nice day.